All right, guys, we're still in Chapter 9, Classes and Objects. Now, really, I hope that by the time you get to this class, no pun intended, by the time you get to this course, you've already taken Java or something like that, and you already have the idea of classes and objects, right? So, I don't want to do 4 or 5 or 6 lectures on this chapter. That doesn't mean that we're blowing it off. And the differences between this language and others, do want to highlight. And, I want to do a good job on it, but, it's possible this will be the last lecture on it. We'll see. And then the next lecture, what I want to do is veer aside and do file I/O, just because file I/O is awesome, and it is something that dramatically differs from language to language, right? If you remember Java, it looks completely different than how you did it in C++. So we talked a little bit about how an object has data, which we can call instance members or instance variables. And then C# adds something called a property. And a property is, in effect, an instance variable that has its own methods attached to it, so that you don't have to write getters and setters for it. You can, but you don't have to. Because in the past, if you've done this kind of stuff, you probably did this. Class whatever, right? And then you had some private variables, right? I had a private int a, and then I wrote a getter for it, right? Public, int get a, right? And it would return this dot a. And then we'd write a setter for it, right? Void set a. And then you would do this dot a equals the a parameter passed in, right? That's called data encapsulation, and the whole point of it is so that later on, if this kind of data needed to be changed to a float or something like that, then these would not necessarily need to change. Now, yeah, if you're just changing that, you'd probably change these to, floats rather than ints. But if the converse was true, if you were changing it from a float to an int, you might want to keep the interface the same. You could change this you could store this in a completely different format. The programmer who's using your class doesn't need to know anything about how the data is stored. They just need to know that there is some piece of data that can be rendered as an int, and they can call get on it, and if they feel like setting it, they can do that. The key point to that, besides the fact that the programmer, who is the end user of your class, doesn't need to know anything about the internal storage of it, this could be stored in an array of it for whatever reason, is that you can do data validation. You can make the set function check to make sure you're setting it to a valid piece of data, right? Maybe we're going to forbid non-negative values, right? And it could throw an error, or print an error message or something if this value is being set to something negative. And the idea there is that the state is considered to be the value of all the variables, all the instance variables. That is the state of the object. And if you properly implement, all your getters and your setters and your constructors, then you can guarantee that that object is in a good state, that it's never going to reach an invalid state. Like if you write a fraction class, and you're going to have 2 integers on it, a numerator and a denominator. The denominator is the number that goes on the bottom of the fraction. It better never be 0, or else it's an invalid fraction. So you would probably make the set denominator method forbid zeros. And if they try to put in a 0, I don't know what you're going to do. You're going to generate an exception. You're going to print an error message. Who knows? But you can make sure that it's always in a valid state. And that is the point of encapsulation. That's the same in all the languages that do object-oriented programming. So that's an instance variable with getters and setters. To use it, you have to have some client code, driver code, some textbooks call it, that's going to use your class, right? A equals new, A, right? And then you feel like setting, that variable equal to 1. That should be lowercase. A, okay, this is really stupid. How about a myvar is equal to new a, and then myvar dot set a. We're going to set it to 10, and then later on we're going to do something else with it. Get the variable out of it. var dot get a, right. That probably looks familiar if you've done object-oriented programming before. Now, what would be neat and what C# gives you the ability to do is something more along the lines of this. You know, you're going to create a new class, a new object, and then you're going to do my var, dot a equals 10, and int x equals my var dot a. But you still want data encapsulation. You still want to be able to provide getters and setters. You can do that in this language. You can also do it kind of in C++ by doing something called overriding the assignment operator, but certainly cannot in Java. You cannot create a variable. You cannot create anything that looks like and is accessed by as an instance variable is, but also behind the scenes has getters and setters. And in this language you can. So typically what you do, what the books recommend, is that if you're going to do that, well, let's go to the PowerPoint. Those things are called properties. No longer called instance variables. It's a member of the class that provides access to a field of the class, and field is synonymous with instance variable. And it defines how the fields will be set and retrieved. Properties have accessors. They have set accessors and they have get accessors. You can make a read-only property that only has a get accessor. So, for example, let's zoom in on this. Here we have our instance variable. Textbook calls it a field, called ID number. But we create a property that exposes this to the outside world. And so what does it do? The getter returns ID number. Notice that the property has an uppercase letter as part of its variable name, and the instance member has a lowercase letter. That is a C# convention. Elsewhere, I think we've always said, variables should have, lowercase letters at the beginning or whatever. But C#, the textbook, just roll with it. If you're implementing a property, then you can make the first letter uppercase, and that could distinguish it between the instance variable that it's hiding, right, lowercase. And so it has a getter that returns it, and it has a setter that allows us to set it. Notice the syntax. The syntax looks weird. Although this is a function, we don't put parentheses after it. We don't give it a data type because that's assumed from that. And on the setter, we don't put, void, and we don't put parentheses in parameter list because the parameter list is, it provides it for you behind the scenes, the compiler does, and the parameter is always called value, and the return type is always void. But if you want, you can do what's known as an implicit parameter. An implicit parameter is one that isn't based on the variable behind the scenes. You're not going to provide a variable behind the scenes to hold its value. You just want to provide a property. You want it to be an int or whatever. You want it to have the cool getter and the setter, and then later on, if you decide that you need to do more sophisticated stuff with it, then you can go ahead and provide the variable behind the scenes. I hope they have an example of it. So we can do what's known as an auto-implemented property, an automatic property. It's created for you with the assumption that the set accessor should simply assign a value to the appropriate field, and the get accessor should simply return the field. So when you do that, you do not need to provide a field that corresponds to the property. You do not need to declare an instance variable. And that looks like this. That does not look like this. Here we do. Here we go. Right? It looks like a variable declaration, but instead of just terminating it with a semicolon, we put curly braces here, and we say get semicolon, set semicolon. And it does all the rest. It provides all the getter code, all the setter code. We don't have to write all the getter code and all the setter code. All it's doing is simple stuff, right? It will get that value, provides a getter, and it provides a setter, and you access it just like as I was showing, right? A dot, B to get the value of B out of it rather than doing A dot get B. And if you want to set the value, you do A dot B equals 100 rather than A dot set value, parentheses, 100, whatever. So if we were going to modify this code to have an automatic field that didn't need a private, an automatic property which did not need this instance variable behind it. So we're not actually doing any data validation, but we want to provide the nice syntax and the option of coming back in later and improving it. Then the class would look more like this. Class. Right, this is a new class. I'm going to call the variable I because calling A was confusing up here. And as a matter of fact, for my notes, I'm going to change all these. Right. Hope that makes sense. I didn't want to be A dot A and A dot A. That was hard to understand, right? Was for me anyways. Okay. So here's what our class is going to look like. Public. It's going to be an int, and it's I, and it's going to have a getter and a setter. That's it. Then if you want to use it in your client code, B my var equals new B. My var dot I equals 10. And then int x is equal to my var dot I, right? It's treated just like a normal instance variable. The thing is it actually has a getter and it has a setter. And if you feel like it, you can go and expand this stuff to do more complicated stuff than just getting and setting the value. So you're setting it up. If anytime you're going to create instance variables in your C# code, you may as well make it an auto-implemented property. It could even be private if you didn't want anybody to be able to access it but yourself. But that way you're set up so that later on you can go back in and modify the behaviors of the getters and the setters if they need to be more complicated. The framework for doing so is already set up. And the syntax for accessing them is just your standard old .i syntax. Now on the other hand, if you like doing get I and set I because you've done that in Java or whatever, that's totally cool. There's nothing preventing you from doing that. It's just kind of like this is the C# way, right? And if you're coding in C#, maybe you want the code to look more like Java. Maybe you want the code to look more like what an experienced C# developer would do. It's up to you. All right, now I didn't understand what they were talking about implicit here. Oh, the implicit parameter is one that's undeclared and gets its value automatically. That's this thing, right? Up here when I was writing a getter and a setter, let me expand this so that it's not all in one line. You know, that makes it look tidy in a way, but we're more used to seeing it look like this in our code. Oh. I didn't even have a property shown, illustrated, that did expose a field. You know, I kind of went straight from doing a getter and a setter to an auto-implemented property here. So I skipped the intermediate step. Here's what this would look like. I swear I did it. Did I not? Oh, I guess I just showed it on the screen rather than actually type it in as code. Maybe that's good enough, especially since I know I already did a little bit of this lecture last time. So when we look at our code, where's our getter? Where's our getter? Right here. It's got an implicit parameter on the setter, right? And the name of the implicit parameter is value. So that's what they meant by implicit parameter. I kind of bossed that as I was going over that the first time. And this is our classic example of exposing a field, an instance variable, with a property. If I was going to follow all the C# rules exactly, then I would have made this an uppercase I here. Just because they say properties ought to be uppercase. Meh. Do I agree with that? Yeah, whatever. I didn't invent the language and I didn't invent the convention, so if I was going to stick with them, then I'd roll with that. So, as we mentioned before, methods usually are declared public, fields are usually declared as private, properties are usually declared public. You should always hide your data when possible. Access to it should be controlled by well-designed accessors. Now, in some languages, you kind of get annoyed with writing getters and setters, you know. You're writing a point class, right? And so you put an X and a Y int in there, and that's enough, right? You really don't want to fluff it out with getters and setters. And, you know, the syntax for it's kind of confusing. It doesn't make the code look as clean. And there's a thought that you should try to avoid cargo cult programming. I don't know who came up with the term of it, but it's doing stuff just by rote, by ritual, even though it doesn't actually add anything to your code. And some people think that fluffing out your Java code with getters and setters is cargo cult programming. You're just doing it as a ritual, and it's not actually necessary to do.
How else would you access your...
Well, then you make them public, right? You just make all your variables public, and you run with it, right? So, you know, you're ignoring the idea of data encapsulation there, and C programmers, people who come up from C, you know, that's how they've always done it. They just use structs, and a struct is a class, right, where everything is public and you don't have any methods attached to it. So that's their mindset. They think that it makes the code cleaner. But C# gives you these properties, meaning that there's absolutely no reason to not use that in a C# program. And
so is encapsulation necessary or not necessary?
Well, is it necessary or not necessary? It's not necessary. It can just be a good idea. It's a good idea if you care about maintaining the state of the data to always be in a good state. If your setter is going to somehow check it and validate the data, then it's very necessary. Or if the idea behind encapsulation is that you can maintain good state of your variables, and if later on you need to change the way that the function works behind the class works behind the scenes, then you hopefully don't have to change the interface for it. If we decide that every time you set something, it's going to write something out to a file, great, you can do that, right? Where you could not do that if you were not encapsulating the data. So it's a good idea. It's nice that C# gives us a way to create variables that actually have the getters and the setters. Okay, so along with our instance members, we can create constants, right? If you're going to create a constant in your class, in this language you declare it as static, right? Public, static, const, int, pi is equal to 3. What a world we live in. Pi is equal to 3. All right, now I'm not sure I got the syntax of that right. I'm not sure you have to put the keyword static there, or if putting const there automatically makes it static. The idea behind that is that if it's a constant, you don't want to have to declare the class in order to access it, right? When you access math.py, you don't want to have to do this. Math m is equal to new math, and then, you know, use m.py, right? So you want this to be a class member, not an instance member. And to make it a class member, you make it static. Remember that distinction. Static variables and static functions, static methods are considered class members because you do not instantiate an instance of it in order to access them. Let's get the actual syntax of that now. So, a named constant within a class is always static. It belongs to the entire class, not any particular instance. We're going to give ourselves a nice example of that. I saw one up here. Okay, so for some reason their motto is static. It's shared by all carpets. So they declared it as public. Oh, and I'm sorry, I went into C++ mode and I started suffixing the words public and private with colons. That is C++, that is not C# in Java. We should remove those. So if you were typing this code in, which I have not been, then you were getting syntax errors when you did that. Apologize for that. Now what was the real point of that? Okay, anyways. Public const string motto. They did not declare it as static. So apparently they're just stating that it is static. I bet if you put the static keyword in front of it, it would not be a static there. It would just be superfluous. The this reference. Yeah, the fact that this is called implicitly passed is interesting. Maybe you remember in Python, if you've taken Python, that you would define a class like this. You would have an init method, or all of your methods actually, had as their first parameter a word like that. And then you could do self.x equals x, self.y is equal to y, self.z is equal to z. You had to pass a reference into the object. Well, you didn't have to, but when you made the object, right, my object is equal to a, like that, that would call the init function, and you would pass in some values since I had, put some parameters in there. You don't pass in anything for that. It gets passed in all by itself, just by the fact that this is an object. And then say that we needed another function that would print a, right? So we could call it print. You still have to provide a reference here so that you can do this, print self.x, right? Something like that. These are how you declare the instance variables in Python, in this language. The real point is that when you call these functions, a reference to the object is generated and passed in. If we wanted to make it look more like all these other languages, we would not use the parameter named this, self, we would use the parameter named this. And now, a Java or a C++, C# programmer walking in on Python would know instantly what it's doing. They'd be a little bit puzzled. Well, how do I pass this in? And then they'd see an example and they go, oh, I guess I don't, right? It's generated automatically by the function call. I don't have to pass it in. And that's true. So when I did my object.print, that's all I do. I don't pass in anything. Well, in all these other languages like Java and stuff like that, you don't explicitly see that keyword and you don't give it a name. It's just always declared as, quote, this. You get the this reference provided to you by the compiler. And that's why we can do things like this. Again, no pun intended. Talking about the this keyword is hard. You keep using the term this. Anyways, right, so you don't define anything here called this. It's just given to you by the language. And what it means is that the thing that follows the this reference is a member of the class, an instance member of the class, or a property. I wonder if I could access a constant that way as well. A lot of compilers will complain if you use this dot in front of a constant name. Not sure why. Seems reasonable to me. But what they would want you to do is to act, okay, where's our example of a constant? Right here. If we were going to write something that accessed that constant, well, down here you would do it like this, int p is equal to my var.py, like that, except you don't prefix it with the instance because it's a class variable, so you prefix it with the name of the class, like that. And so if you were going to write a function that used pi, for whatever purpose, you would not say this.py, you would say b.py, because it's a member of the class and not of any particular instance. So your rule of thumb is that if you're accessing an instance variable or property, use this dot, and if you're accessing a constant, use the name of the class. Do you have to use the this keyword? Well, in Python you had to. You had to use self dot or this dot. In this language, you don't unless, ooh, look at that, I made a mistake here. Unless there's the possibility for confusion between the parameter name and the instance variable name. So if I called that A, like here, then I wouldn't need this dot in front of it. I can just do I is equal to A, like that, right? Because there's no, there, right. There's no possibility of confusion between that and that. But if this is called I, because I think that that makes it look neat to tell myself, you know, whatever, then, you know, I is equal to I is not going to work because both of these would be referring to that, would not be referring to that. To get it to refer to that, we use that keyword. So when you call the method, it automatically passes this reference to the method, which is a reference to the object. Tells the method which instance, which object you're using. Read the chapter if this is the least bit confusing. Understanding constructors. A constructor is the method that instantiates the object. Every class has a constructor, even if you don't see it. In Python, you had to provide a constructor, right, to declare all those instance variables, but that's Python. In Java, you get a default constructor. In C++, you get a default constructor. In C#, you get a default constructor. It's provided by the compiler as it compiles. The constructor doesn't have any parameters, and you don't get to control what it does. Doesn't do anything. The default value of the object is the value of the object initialized with the default constructor. There's something I don't like about that definition, but I'm going to ride with it. The default constructor sets the values of the instance variables. Now my beef with that explanation is that if you provide your own constructor, then there no longer is a default constructor. Those variables are still getting initialized. So obviously it's not really the default constructor that is initializing that stuff.
And I think, from what I understand, if you have a parameterized constructor and you, for some reason, want an unparameterized constructor, you have to then create it.
Yeah. The comment, and it's absolutely correct, is that the default constructor goes bye-bye. The compiler no longer provides one for you if you create a parameterized constructor. So let's make our point class. And I'm not going to use fancy properties, even though I just lectured about how awesome they are, right? Great, that works just fine, right? So if in my client, if I want to make a, you know, point p1 equals new point, and then I would feel like setting those values, p1.i is equal to 10, right? p1.y is equal to 20. That's all well and good. Now what if I want to do this syntax? Point p2 is equal to new point, and then pass those things in as parameters, right? Like that. Set x to 10, set y to 20. Okay, well, we could do that. We can come up and provide a parameterized constructor for it. So a constructor has the same name as the class itself. It has no return type, and if you want a parameter list, you better provide it between the parentheses. So public point, and I want it to accept two variables, int x and int y. And what is it going to do? It's going to set this dot, not x and y. It's a point. It should be called x and y. Where did I come up with I and j? All right, so this dot x is equal to x. This dot y is equal to y. Now I've broken my code. This no longer works. We no longer have a default constructor. The compiler removes it. It stops providing it to us. But here's what I mean about the default constructor not initializing those things. You know, even if we cut that out, and then we create an object with that, x and y are going to be completely ignored, right? You know, just to prove the point, I can make that a string instead, you know, and pass in, you know, hello there. By the time we're done with this, x and y still get initialized to 0. So clearly wasn't a constructor that did that because we don't see ourselves. Okay, anyways, I don't know. Good way of you know, reconciling what the book there says. That there must be some piece of knowledge I don't understand. Okay, so that works. However, this no longer works. We no longer have a default constructor. We have to provide a non-parameterized constructor since we're not getting a default constructor. Well, a non-parameterized one is just one that doesn't have any parameters, right? That's enough to satisfy it, to get it to compile again. If you feel like setting x and y equal to zeros or some kind of default value, totally cool, you can, but that's enough. You know, got to replace the default constructor. If you provide a parameterized constructor. And this is mandatory, not optional. And it's not just true of this language, it's also true of C++, I hope. It's absolutely true of Java. C# is just a cooler version of Java. Now you may find things in Java that aren't in C#, but there was an arms race between the two to implement features because C# was Microsoft's version of Java after Sun Microsystems sued Microsoft to stop them from making any changes to the Java language. So they
Speaking of lawsuits,
yeah, big lawsuit.
I said speaking of lawsuits,
Yeah.
you won't be able to program with Java unless you pay Oracle.
That's not strict. Yeah, the comment is won't be able to program in Java unless you pay Oracle, unless the things have changed. That's for the mobile versions of Java, like Android and stuff like that. You have to pony up for the license, and so the reason for that, or maybe you don't, but for the phone manufacturer to provide Java on the phone, they have to pay.
I just know Oracle likes to sue people, and they like to get paid.
Exactly, right. Yeah, Oracle loves their money. So that way the phone manufacturers cannot implement Java on their phone. They have to pay the license, right? So it's not free to put Java on a phone like it is free to put Java on a PC. Clever move on Google's. On Oracle. So what did Google do? They didn't put Java on their phone. Instead, they created an identical clone of the language, but they did it in what's known as clean room programming, where they didn't use any of the source code for Java, and they just duplicated all the functionality, and then there was a big lawsuit, and the lawsuit end point was that you cannot copyright the syntax of function calls. So they were free to go ahead and clone.
Like you can't copyright the functionality? Or the
Well, right. You cannot. Functionality can be copyrighted in terms of patents. You can, if you come up with a cool idea, and that's a lot of controversy, but you can copyright an idea, a new sorting algorithm, or the way that data is pulled off a server, or something like that.
If you reverse engineer with a different language, it's still infringing on their copyright.
Right, but if it's not a brand new idea, and there are very few brand new ideas in programming languages, then you can create another language that does the same thing, and you can even make it mirror all the method calls of somebody else's language. So,
Is that Flutter?
pardon me?
Which language was that? Was that the Google made?
Jarvik, I believe, or Darvik with a D. Yeah, is the Java clone. So if you become an Android programmer, you're essentially programming in Java, but it's called something else, and it's very likely, in my mind, that Google has added extensions to it, right, to do stuff that Java didn't do. Just because, why not? If you own that language, you can make it do whatever you want it to do. So if those lawsuits, those precedents have been set in, when Microsoft was doing C#, they could have made C# an exact clone of Java. But instead, they modified it, Microsoft, brilliant IQ, IQ of 1 million engineers, they wanted it to do something, and they used it as a framework for building the entire .NET architecture, and so they expanded it. And then, like I said, there was an arms race every time a feature was added to one. The other guys would turn around. So a constructor, you get a default constructor. If you don't provide a constructor, then all the values, all the instance variables just get initialized to 0 or whatever you specify, right? If I did this in my point class, I said, by default, every object that comes up is going to have an x and a y value of 1. That's great. Yeah, whatever. You don't have to provide a constructor in order to have those default values assigned. You just declare them when you're declaring the class. So a parameterless constructor is one that takes no arguments. Now colloquially, a lot of people, including me, call that a default constructor. Well, I'm going to provide a default constructor, right? It's called, and it doesn't take any parameters. It's not strictly speaking the default constructor. The default constructor is the one that the language gives you. And you have to replace it with your own, but at that point, it's no longer called a default constructor. It's called a parameterless constructor. I'll goof up and I'll say, oh, I'm going to provide my default constructor, when what I should be doing is saying I'm going to provide a replacement for the default constructor. So anyway, it's not a default constructor, but it's parameterless, and so it's setting pay rate equal to a specified value. So whenever we create an employee, the pay rate's going to be set to $9.99. The name is not going to be set to anything, and the ID number is not going to be set to anything. Now the employee constructor could also have set those values, but they decided not to. Wait a minute. Oh, okay. I was about to complain. Pay rate is not declared up here, but that's because it's a property. It was declared down here. I would have declared all my properties up here with the instance variables, right, just to make them more obvious. But really, you can in this language, unlike C++, you can list these things in any order you like, right? If you feel like your variables ought to go down at the very bottom of the class, whatever, you can do that. So a constructor initializer, a clause that indicates another instance of a class constructor, should be executed before any statements in the current constructor body. You may remember doing this in Java if you've done Java, where sometimes you have reason to call the constructor of a superclass, the parent class. Here's the syntax for doing it in this language. In Java, what you did is you put that in between the braces. In this language, you put it following a colon after the definition of it. And what this means is that when you create an employee, it's going to call the constructor that accepts these two numbers. And so then it would jump here and it would find a constructor that accepts two numbers and it would run that. And so here we have a constructor that accepts no values, and so they make it call the constructor that takes two values, but they give default values. And here we have a constructor that accepts one value for the employee ID, but they don't give one for the salary, so we call the two-parameter constructor, but one of the values we give in a default value.
Can you show how that's done, please?
Yeah, let's do one of those. In fact, it's about time to crank up a project and do this. So C# console application. I've already forgotten what number we're on. QRST, we're on U. All right. So lecture U. Console app. So we're going to write a little class that represents like a character in a video game, and he's going to have a health and a strength and an armor rating, right? And so just like in any game, you know, every time you go up a level, his strength goes up, and if you buy some new armor, his armor rating goes up. Maybe we'll just do, yeah, health and attack and armor. How about that? That makes sense to me. So we're going to write a class called player. And it's going to have several members in it, right? Int health, comma, armor, comma, attack. But I'm going to implement those as properties after a little while, maybe, if I want to be a good programmer. Down in my client, I want to be able to do this. Player P1 is equal to new player, but I want to be able to set those three values. He's got a health of 10, he's got an armor of 1, he's got an attack of 5, or whatever. We're not going to actually implement anything that uses those values. This is just an example. So I'm going to provide a parameterized constructor that sets those three values based on its parameters. So, public player int I1, X, Y, and Z. This is lame, really lame. Okay, I'm going to abbreviate it. H for health, A for armor. Well, no, because then I have attack. Okay, armor and attack. All right, how about defense and attack? All righty, health, defense, and attack. So H, D, or int D, int A. Now, normally I would actually type out those entire variable names, and if you feel like doing that, great. So health is equal to H, defense is equal to D, and attack is equal to A. So we have a parameterized constructor. We no longer have a default constructor. I wish these zero reference things were smaller because they take up a lot of space on the screen, making it difficult for me to scroll up and down. All right. Anyways, I would also be able to do this. Player P2 is equal to new player, right? I need to provide a parameterized constructor. Excuse me, a parameterless constructor to replace my default constructor. Well, I can do that. Public player doesn't take any parameters, but when it's called, it calls that constructor, and we assign a health of 10, a defense of 0, and an attack of 0. Like that. Oh, wrong place for the colon, semicolon. That makes sense, and I could provide other versions of constructors that would pass in different pieces of data there. And when we do this, that's the very first thing that gets executed. If there's something else in here that happens when we create a player, don't know what, console.out.write line, creating a player. And let's go up here and add a console.out.write line, creating a player, but we're going to list the attributes of the player at that point. So I'm going to modify the console.out line, write line to have 3 parameters here. Creating a placeholder 0, 1, 2, and what's it going to print? It's going to print out H, D, and A. Build it, make sure I don't have any syntax errors. I'm going to scroll back down to the driver code so you can remember how we're calling it. We're creating 2 players. I'm going to change these default values to something much more recognizable. Right, 12, 12, 12, 13, 14. Right. That way, when I print out the values, right, we're going to see, you know, something different than the default values of 10 and 0 and 0. bottom of main. Console.read key. Alright, so you see what happened when we created the first player? It was created with the values 12, 13, and 14. It called that constructor directly. When we created player 2, we didn't provide any parameters, so it called the default constructor. But what's the very first thing the default constructor does is it calls that. So it jumps up here and calls that function. And that's what we see in our output, is that it ran up here, it printed out, it assigned all those values, it printed out the message, then it came back, and then it executed the body of our replacement default constructor, our parameterless constructor. Now, could you accomplish the same thing? Could you just make your default constructor set health equal to 10, defense equal to 0, attack equal to 0? Yeah, you can. This is a more concise syntax for pulling that off. And maybe this constructor does 10,000 lines of code, right? Which you would not want to duplicate inside your default constructor. So you just call the parameterized constructor, but customizing the data that you want to pass to it. That makes sense?
Yes.
Okay. Using the read-only modifier in a constructor assigns a value that cannot be changed. The value can be assigned at runtime rather than compile time. They can get their value from user input or the operating system. Now, all of that sounds kind of odd to me, because if it's read-only, how could you ask the user to type it in? But we'll see our example here. ID number is a read-only variable that is not set. Don't do it. The ID number field cannot be assigned a value after construction. The statement generates an error. But the constructor can set it. You know, even though it says read only, we can set its value later in the constructor. So it's not really a const, because if we said const here, we'd have to provide a value right when we declared it. Read only means that once it's assigned, it cannot be changed, and that it can only be assigned in the constructor. Object initializer allows you to assign values to any accessible members or properties of a class at the time of instantiation without calling a constructor for parameters. Only works if it's got a default constructor. And so when you're using that, I'm not sure we have a class right now with a default constructor. Let's make a point class that's just got X and Y. So this is the end of, whoopsie, and I'll change that while we're running. This is the end of the player class. Now we're going to write a point class. It's going to have X and Y. I spaced out on the syntax for the public int I, and then, all right, we're going to get a little bit fancy. Public int X with a getter and a setter. Public int Y with a getter and a setter. Why did I do that? Just to remind myself of the syntax for creating auto-implemented properties. So when I want to create a point, can I change this so that it all fits? Well, that's not doing a dang bit of good. the zero referencing, like I said, they take up a lot of space. So anyways, down here in main, when I'm ready to use my point class, point, origin is equal to new point. That would work. But I can also do point O2 is equal to new point. X is equal to 10. Y is equal to 20. Like that. And it, whoopsie, apparently I'm doing it wrong. Let's go back and look at the literature. Why are they showing two different syntaxes for calling it?
Because the first one is the one where you reference the variable name and then you like initialize it inside. If you put that in in Visual Studio, you'll see it better. Yeah, you can do that. Which means you don't have to parameterize your constructor.
Right.
Which is one of the funny things about C#.
So point O3 is equal to new point. What if I do add the parentheses there?
I mean, if you have a parameterized constructor, you're fine, but that way that's above the one you're writing now is like built-in method for C#.
Okay, but this isn't, yeah, I see what you're saying, but I think that these syntaxes are absolutely synonymous.
Yeah.
Yeah. So, I would go with this one, just because it looks more like all the other constructors we've ever called. But anyways, so what this does is it creates a new point. We don't have a parameterized constructor to set the values of x and y, but we can just do so anyways, right? Set the properties. Syntax unique to C#, and when I say unique, I don't know how to do it in C++ or Java. Other people may have adopted it from C#. Would not surprise me if Java stole the syntax someday. And when I say steal, I'm just being silly. I think, adding things to your language and then learning from other things is always a good thing, right? They all stand on the shoulders of giants. So object initializers mean that you don't have to create multiple constructors, right? You can just provide whatever information that you want to and whatever information you don't, right? If I don't want to provide a y value, great, just don't. Really bugs me. Gotta do that, sorry. They provide both syntaxes. I'm going to use the one that I like, but you can leave the parentheses off. So here we have three different ways of creating these points, right? We can do so and let all the values be set to default values. We can do one that sets both x and y. We can do one that both sets x but leaves y at its default value. And we didn't have to write three constructors to do that. We just accepted the default constructor and we invoked the creation of it in different ways to set the variables. And you may recall that we've seen something like that. If you provide, you can do named parameters, right? Static void foo int x equals 3, int y is equal to 4. Those are our default values for those. I'm not going to even do anything with them. But if I want to call foo, I can do that. And then in here, x would equal 3 and y was equal to 4. Or if I want to, I could say like that. Or maybe I can't. Oh, is it x colon? Yeah, sorry, it's not equal, it's colon. That's how you differentiate it when you're calling it. Okay. There. So, when this is called, x will maintain its default value, but by the time, well, we better change it to something else other than 4, right? But if we printed out y in here, it would equal 10. So those are named parameters and parameters with default values. I really thought we were going to be close to the end of this. But here we hit the idea of overloading operators. This is something that's absolutely not possible in Java. It's probably worth a lecture. So we will combine this with our lecture over file I/O. So we're going to stop there. Do we have any adequate homework already queued up? Let's find out. Sorry guys, as I scroll up and down, I thought I saw something. I'll pause it while I figure it out. Okay, here we go. Upcoming homework, being assigned as of today. Let's go ahead and take a look at it. Got a typo in it I need to fix, so I'll fix it. Alright, so we're going to create a class called animal that has the following members. You don't have to implement them as properties. You could. You can make them auto-implemented properties if you're feeling all buffed up about it. So you're going to need these things. What is an animal? Something that's got a species, a kingdom, it's got a certain number of eyes, a certain number of teeth, and a certain number of feathers. Now, does every animal have eyes? No, then it would have, 0 eyes. Chickens don't have teeth, they would have 0 teeth. A lot of things don't have feathers, they would have 0. Okay, anyways. And so it's going to have a public property called kind that exposes the kingdom field. If we're going to do it the book way, we would call it kingdom with a capital K. If you felt like doing that, that's okay. So, that property's set method should make sure that the value is not empty. Right? If they try to set the kind without, but they just pass in an empty string, then it should display an error message saying kind cannot be empty. And so then it needs some methods. It needs a default constructor that doesn't do anything. It needs a parameterized constructor that accepts all 5 of those values. And it needs one called display. And you can kind of guess what these do. Parameterized constructor doesn't need to do much. The default constructor, here I am calling it a default constructor. I really should call it parameterless. Replacement default constructor. All right, so we know what that does. It doesn't do anything. We know what this one does. It's going to set all of the properties and the values equal to whatever is passed in. And then display is going to print out information about it. So what is your main program going to do? It's going to create an array of 5 animals. We're going to create 5 animals using parameterized constructors like A1 is equal to new animal, and then copy that animal reference. I don't put the word reference here, but it should be into an element of the array. Add a static method that will go through the array of animals. I don't know why I say to either class, your choice. But yeah, I'll let you figure out how you want to do that. That will go through the animals displaying each one. Right, so you need some kind of method somewhere that you pass it an array of animals and it'll print them all out. In other words, it could call the .display method of every animal. Add a static method to the same class that will search the array for all animals that are birds and display only matches. Now, if you want, you can genericize it so that it doesn't just search for bird, but you can specify the string that you wanted to search for. And then have your code test that method. The program doesn't have to do any data entry, right? You can just create 5 different animals, stick it in the array, call the method that's going to display the contents of the array, and then call the method that will search for a bird or whatever you want and display nice and results. Okay. And my hints for it. All right, that makes sense? Hope so. Contact me if you have questions.